Hi, welcome to WOW TV. My name is Angel and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today, you're going to learn about a man called Hero, his invention, and how it can be used to learn more about Newton's third law of motion. Are you ready to get started? Let's go. Although you've already learned about Sir Isaac Newton and his laws of motion, let's take a few minutes to review. Sir Isaac Newton was born in England in 1643 and is one of the most important scientists in history. Newton developed the theory of gravity, the laws of motion, a new type of mathematics, and made developments in the area of optics, such as the reflecting telescope. Most importantly during his work, Newton produced the three basic ideas that are applied to the understanding of motion. Other scientists have studied, tested, and verified these ideas so many times over the years that now we simply call them Newton's three laws of motion. In studying his first law, you learn that an object at rest stays at rest, and an object in motion stays in motion until acted on by a force. In studying his second law, you learn that when an object has a greater mass, it will take more force to accelerate it. We use an equation that relates an object's mass and acceleration to the amount of force involved to cause motion. That is, force equals mass times acceleration. His third law taught us that for every action, there is an equal and opposite reaction. Let's think about that action as a force. If object A exerts a force on object B, then object B also exerts an equal force on object A. Think of it as an action and a consequence. The second action happens because the first action caused it. Now, let's go back even farther in time. There was a man called Hero of Alexandria. He was an ancient Greek mathematician and engineer, and he is famous for his many contraptions and experiments. One of his most famous inventions was an eelopile. Today we call it Hero's engine. It was a spinning copper sphere that was propelled by a thrust produced by a jet of steam. It was an early demonstration of the action and reaction principle stated by Sir Isaac Newton 1700 years later. Your activity today will simulate the operation of the classic engine he invented more than 2,000 years ago. Teachers, you have very specific directions in the binder for your students to follow. But let's go over them briefly to give you an idea of how to set up your tests. When you're ready to start preparing, teams should only punch holes in their first can for right now. The other cans are there for future tests with different variables. The first thing you'll need to do is punch holes in your empty cans. I suggest you make sure they're completely empty and dry. The idea is to punch the hole without crushing the can's sides. Place the nail point near the bottom rim of the can. Apply pressure with the nail, turning it if necessary to make the hole. When the hole is punched, push the nail head to the right or to the left. This will angle the hole so that water will stream out at a slant to produce thrust. Rotate the can a quarter of a turn and punch a second hole. Again, angle the hole in the same direction as before. It is important to work carefully and gently so you're adding holes without crushing the can sides. Repeat the procedure so you make 4 holes in total. Then tie a string to the pop tab. Place a sticker or a dot with a permanent marker near the top of the can. This will help you count the rotations of the can. We'll pause here as each team prepares one can. I'll see you back here in a bit. Teachers, please make sure students have a data recording sheet before they begin testing. If you haven't set up testing stations yet, let's talk about that. You'll need a few water tubs around the classroom. They don't need to be completely full, just enough to submerge the cans. When you're testing, I suggest having only one team at a station at one time, and remind them of the importance of keeping the water in the tubs. When engines are filled, they should not be raised any higher than the rim of the tub. This will keep water coming out of the holes from spilling onto the floor. Okay, let's talk about testing. Students, when it's your turn at the testing station, immerse the can in the tub of water. When the can is full of water, lift it out by the string and observe the rotational motion. Count the number of rotations and record the results on your data sheet. Once you've recorded those rotations, we will call that your control experiment. Using your data sheets and now your extra cans, you'll see that it is your objective to design an experiment to find a way to increase the number of rotations the Pop Can Hero engine makes. You can adjust the size of the holes and the number of holes, for example. Can you think of anything else? Teachers, after all testing is completed, discuss with your students the force that caused the cans to rotate. There are some other suggestions in the binder of things to discuss and possibly even try. You did a great job today. Thanks for joining me. And teachers, thank you for using this WOW lesson. Please check out more at our website at wpafbstem.com.